So our author says that now that we've drawn a line that reasonably fits. Okay, do you agree? It's reasonably fit, right? We want to find the equation of that line. So he talks about a procedure here that you can go to. Find the slope using the slope formula and then substitute in there. In other words, we're going to pick 2 points on this line. So I'm going to call this point what that looks like 15,400. And where's another, we'll call this one, 29,600. All right, we're going to claim that that's our points. And we're going to use those 2 points to write the equation of a line. So there's all kinds of different ways to do this for these 2 points. He suggests finding the slope, which it's not a bad review. You do 600 minus 400 divided by 29 minus 15, and that would get our slope. And then we're to pick one of these 2 points and plug it into our equation for those values and solve and blah, blah, blah. But I want to show you how we could use technology to do this very thing that he's suggesting we do. So here's our old data, and we're going to take those 2 points. Let me just type them in here so that we remember what they are. Here's the first point, and then the second point is 29,600. I claimed those were 2 points on that line I drew, and we're going to, oops, I forgot to put in the 600. We're going to test to see if that's true. So I'm going to label those on. That looks like it's within our data. It's actually not great, right? You can see it's a little bit above. So let's write the equation for this. So what we really need to do is create a table here and put these points in as a table. And what we're telling Desmos is that these 2 points represent a scatter plot of some sort. Here's my zoom fit of the 2 points. Notice they're here in, boy, what are they, green? Okay, can we change that to something, let's do orange so we can better see them. So here's the point, there's the point. Now we want the equation of that line. So if we were to use the slope formula, we would do that 600 minus 400 divided by, notice I put parentheses around the top, so we're dividing everything by the difference of 29 minus, it's supposed to be 15. I typed that in there wrong. Good gracious. Okay, so my slope is 1428, blah, 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 and then we're looking for the y-intercept. Well, I don't want to mess with any of that. I just want to take this special little feature in Desmos where I tell Desmos, take these y2 values and create a regression equation that best models this data, those 2 points. Now notice we get here an R value of exactly 1. We're going to learn what that means in a second, but look here, here's our slope, 14.2857. Here, same thing, 14.2857. And then we also get the y-intercept right off the bat, 185.74. Now let's look, how well did that fit our data? Yeah, not too bad. Although the majority of these green points are below the line, we only have 1 point above the line. So that's probably not too great. So let's go back to our paper here. We got that this was approximately 14.2857. And then to get the y-intercept by hand, we're supposed to do this mess. We'll pick this point. We'll write down our 14.2857 times x plus b, and then we plug that mess in. So we do 400 equals 14.2857. And I'm guessing that you're already losing interest, right? You solve for that, and we get a pretty good approximation for our b that we already have, 185.174. All right, and then our equation is just all this stuff put together. Well, why do by hand what we can let robots do for us? Let me go back to what we did here. We took 2 points and we did a regression on those 2 points. Notice I wrote this down wrong, 714, and got our equation. All we have to do is know how to read what Desmos gave us. So I would take that y equals mx plus b, and I would put this in for m and that in for b, and we get exactly what we've written here. Y equals 14.257x plus 185.714. Okay, so that's our estimated equation of the line. Well, it should stand to reason then that we can get the exact equation of the line. But first, let's do our prediction here. So we're supposed to use this equation to predict the number of calories in a Whopper that has 39 grams of fat. So what we need to remind ourselves is which of the variables represented grams of fat, which represented calories. Well, we always write these as x comma y every single time in the math world. And then we graph them here. It's always x is the horizontal, y is the vertical. That means that this 39 grams of fat we've been given and asked to predict the number of calories is an x value. So we're just going to plug it into our equation. Y equals 14.2857 times 39 plus 185.714 and see what does that spit out. So I'll switch over to Desmos real quick to just calculate that. 14.25287 times 39 plus 185.714, and our equation predicts there should be 742.8563 calories in that burger. That's our estimation. That's how our equation is predicting this value. Now, our equation is not good at all because we drew that by hand here, and then even the 2 points I chose to represent points on this line were not very good either. They were close, but not quite there. So we're going to let technology do what's called the line of best fit, and I've already shown you how to do that. I used this regression equation, y tilde blah, 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 on these 2 points, and I got exactly a line. I know that because my r squared and r values are 1. So let's do the same thing for this whole set of data. So let's put an expression in here. I'm going to move it right up by these. Now, when you work with Desmos, you have to keep track of the labels in your table. So I've got an x1 and a y1 in the table I want to perform the regression on. So I need to do y1 tilde m x1 plus b. There is the line of best fit for these data. Now you can see it's quite different from the red line that I proposed was a good line. And the points all seem to be closer to this green line than my red line. So let's write that value down, that equation down on page 155. Except I gotta look at it, remember what it is. It is y equals 11.7313x plus 193.852. So this is what the equation looks like. Notice where I got the m and the b. I got it straight from what Desmos told me. M equals this, b equals that. Now we're going to use this equation to do the same prediction. So I'm just going to type in that equation, 11.7313 times 39 plus 193.852, and my prediction for the Whopper is 651.3727 calories. So my first prediction, recall, was 742.856 calories. This was the line I drew by hand and then used Desmos to help me figure out what it was. And here's the line that is the actual line of best fit. Notice we're told that the correct amount of calories in the Whopper is 660. So our line of best fit is quite close to that. We're only about 8.7 calories off. So not bad, a pretty good predictor.